An actuary determines that daily auto accident count can be modeled by a Poisson variable mean 4. In addition, the accident counts on different days are mutually independent. Calculate the approximate probability that at least 6,496 accidents occur during a period of 1,600 days. So we have given the daily average to be 4, and we have to find what happens over 1,600 days. So now, theoretically speaking, this can be done by a Poisson distribution because the daily mean is 4, so the mean over 1,600 days will be 1,600 times 4, which is 6,400. But we are talking the probability of at least 6,496 accidents. So it means that we need a huge sum. We need to sum a huge number of Poisson variables if we are to do it through Poisson. And therefore, in order to be able to do that without the computer, which is the case in the exam, we will have to use the normal approximation to Poisson. And the mean is given to be 4. And we know that for Poisson, the variance equals the mean. The variance will be needed when we find the variance over the 1,600 days using normal approximation. So central limit theorem tells us that the distribution of the sum of more than 30 identical variables is approximately normal. And here we have 1,600 variables, which are way over 30. So if there are n such variables, then the mean of the sum equals n times mean of each. In this case, we have 1,600 days, so we have 1,600 times mean of each. So the mean of each day was 4. 6,400 will be the mean of the sum. And the standard deviation by central limit theorem, we square root of n times standard deviation of each. So square root of 1,600 times square root of 4, because we said that the variance equals the mean. So mean was 4, variance is also 4, and standard deviation is the square root of variance. And that comes out to be 80. So let S be the total number of accidents happening in the 1,600 days. So we need the probability that at least 6,496 accidents happen over this period. Therefore, we need to change 6,496 into the z-score. So x minus mean over standard deviation, x in this case is 6,496, minus 6,400 is what we found to be the mean of the sum, divided by standard deviation was 80, so 1.2. So therefore, probability s greater than equal to 6,496 equals probability z greater than equal to 1.2, which is equal to probability z is less than 1.2. And from the normal tables, we can see that 1.2 corresponds to a cumulative probability of 0.8849. So this comes out to be 1 minus 0.8849, which is 0.1151. That is choice B.